Let me ask you a question. What in the world could possibly be hotter than the surface of the sun? You know, the giant star that powers our entire solar system. The answer, well, it's probably a lot closer and a whole lot more dangerous than you think. 35,000 degrees Fahrenheit. That is 4 times hotter than the surface of the sun. It's an almost unbelievable amount of energy, and it's released in a split second. So what is it? That's the temperature of an electrical arc flash. It's a terrifyingly powerful explosion that can happen right in the workplace. And no, this isn't science fiction, it's a very real hazard. Understanding what this is, well, that's the first step to preventing an absolute catastrophe.
And that really gets to the heart of what we're talking about today, the incredible power and, honestly, the hidden dangers of electricity on the job. An arc flash is just one piece of the puzzle, one of several major hazards you absolutely need to be aware of.
Really, it all breaks down into 4 main threats. First, you've got electric shock. That's the silent killer that can literally stop your heart. Then there's the arc flash, that insane burst of heat. Then the arc blast, which is a shockwave so powerful it can throw people and equipment across a room. And of course, there's always the risk of fire. All of these come from the same source.
So, how in the world do we protect people from all this? That's where OSHA comes in. They've put together a whole framework, and it's not just a dusty book of rules. It's a life-saving plan designed to manage these exact risks.
Okay, this specific rule is 29 CFR 1910-332A. Yeah, I know, it sounds super technical, but what it means is actually very simple. If your job exposes you to electrical hazards, your employer has to train you on how to stay safe. It's not a suggestion, it's the law.
So who are we talking about here? It's not just electricians, not by a long shot. We're talking maintenance crews, mechanics, HVAC technicians, even machine operators. Basically, if your job puts you anywhere near live exposed electrical parts, this training is for you. This rule casts a really wide and really important protective net.
Now, this next part is crucial. OSHA makes a really important distinction that everyone needs to get. Your responsibilities are totally different depending on whether you're considered a qualified person or an unqualified person. Knowing which one you are is fundamental to staying safe.
So here's the difference in a nutshell. A qualified person has the deep, specialized training to work directly on or right up next to live equipment. They know how to spot the hazards and what to do about them. An unqualified person, on the other hand, just works near the hazard. Their training is all about recognizing danger and keeping a safe distance. For a qualified person, the knowledge has to be rock solid. We're talking knowing how to tell if something's live, understanding voltage levels and safe distances, mastering procedures like lockout/tagout, and being an expert with test tools and the right personal protective equipment, or PPE.
Now, for an unqualified person, the name of the game is awareness. It's all about understanding the basic danger of shock, knowing why you have to keep your distance, being able to read and understand warning signs, and knowing exactly what to do in an emergency.
All right, so we've covered the hazards and we know the roles. Now let's get into the practical stuff, the essential safety toolkit that turns all that knowledge into actual real-world protection.
First up is something I call the lockout/tagout lifesaver. This procedure is absolutely non-negotiable. Step 1, you de-energize the equipment. Step 2, you put a physical lock on the power source so nobody can accidentally turn it back on, and you add a tag. And then step 3, and this might be the most important part, you verify. You test it with a meter to prove there is zero energy. You never, ever guess.
Next in the toolkit is your armor, personal protective equipment. This is your last line of defense if everything else goes wrong. And it can range from special daily wear clothing all the way up to what basically looks like a bomb suit for the highest risk jobs. Having the right gear is critical.
So what kind of gear are we talking about? This isn't just any old work shirt. It's special arc-rated clothing that's designed not to catch fire. It's a face shield to protect you from the blast, voltage-rated gloves to prevent shock. Even your shoes make a difference. Every single piece is designed to counter a specific hazard.
And finally, we have approach boundaries. I love this way of thinking about them. They're like invisible force fields. OSHA defines different zones around live equipment, and the closer you get to the center, the stronger that force field gets, meaning the risks are higher and the rules for what you have to do and where become much, much stricter.
So we have the rules, we have the roles, and we have the tools. But what happens when people ignore them? Let's look at a real-world case that shows exactly why all of this is so incredibly important.
This is from an actual incident report. A maintenance worker, a 480-volt panel. That's a really common voltage in factories and big buildings. He opened it while it was live, without the right gear. An arc flash happened, and the result was devastating. Severe third-degree burns and permanent life-altering injuries.
So what went wrong? When you look at the root causes, it's like a checklist of everything we've been talking about. The training wasn't there, the lockout/tagout procedure was completely skipped, and that last line of defense, the special PPE, was missing. It was a perfect storm of failures.
And how could it have been prevented? Well, it's just as clear. Proper training would have told him the danger. Doing a hazard assessment before starting would have identified the risk. And making sure the correct PPE was used would have given him that critical protection. This entire tragedy was preventable.
Look, here's the bottom line. OSHA's electrical safety standard isn't just some boring government rule. It's a system that was designed based on tragic lessons learned, a framework built to make sure everyone gets to go home in one piece. It's a lifeline. The only question left is, are you and your workplace using it?